I'm David Bean, and I have the good fortune to live near one of Whatcom County's great treasures, Point Whitehorn, a beautiful promontory in the traditional lands of the Laktemish and Semiahmoo nations. This point of land juts into the Salish Sea and forms the heart of two important protected natural areas. The Cherry Point Aquatic Reserve wraps around the point, protecting a thriving ecosystem crucial to marine and intertidal species such as Pacific herring and other forage fish. Point Whitehorn Marine Reserve is a Whatcom County park that protects the forested upland while providing universal access to viewpoints and beaches. Please note that erosion of the bluff at the end of the 3/4 mile trail through the park has made the stairs accessing the beach currently unsafe to use. The trail passes through a forest of Sitka spruce, western hemlock, western red cedar, and many other species. It arrives at 4 distinctive vistas of the Salish Sea, the San Juan Islands, and the Gulf Islands. Using the stairs at your own risk, you can approach the beach for a buffet of rocks, water, and the plethora of living things that find a home here.
Point Whitehorn is such a great place to experience the magical meeting of land and sea, and perhaps understand just a little bit better why it's so intriguing.
All of this scenery owes its existence to the great glacial advances through this place during the last many thousands of years. If we could time travel back through that time, we would encounter a scene that would look familiar to Captain George Vancouver when he approached what would become today's Glacier Bay in Alaska. He noted in his journal that the inlet was terminated by compact and solid mountains of ice rising perpendicular from the water's edge. Probably an apt description of this spot 12,000 years earlier. The giant Cordilleran ice sheet covered the region at least 6 times during the Pleistocene, or within the last 2 million years. The last glaciation reached its maximum extent shortly after 16,000 years ago, reaching south of Olympia. The weight of ice nearly 1 mile thick at Point Whitehorn likely depressed the Earth's crust by 600 to 800 feet, sinking into the underlying viscous asthenosphere. Rapid melting followed the maximum 16,000 years ago, and ice retreated to north of the present US-Canada border. But it wasn't done. The several phases of the Sumas Stade are responsible for most of the present-day shape of western Whatcom County. Ice re-advanced and stabilized, forming moraines. Then retreated, advanced, and stabilized again, forming well-developed moraines. Meltwaters discharged in a trough occupied by today's Squalicum Creek. Ice-dammed lakes formed and discharged. Sea level lowered and ice retreated across much of western Whatcom County. The Samish River captured the meltwater discharge. Ice retreated more and the 10-Mile Creek channel captured the outflow from the Samish River. Outburst floods shaped the land as glacial retreat continued. Eventually, ice melted completely from the area, and the land rebounded from the weight of the ice, lowering the sea level, leaving fossil shorelines far above the waves. Much of this detailed interpretation of the evolution of this landscape has been gleaned from digital elevation models derived from LiDAR sensing. LiDAR, or light detection and ranging, is a remote sensing method that uses light in the form of a pulsed laser to model the surface of the Earth with great accuracy. The geomorphic map of Point Whitehorn shows the shape of the Earth's surface and the positioning of features on the landscape. Important features that delineate the sequence of events here include the traces of moraines, or ridges of deposition formed as glacial ice stood in the same position for a period of time. As well, the traces of fossil shorelines, now lifted well above sea level, are mapped as the brown squiggles shown here. Really, all the land here is a pile of sediment dropped here when the ice melted. The glacial drift. The bluffs above the shorelines of Point Whitehorn present a window into the varied environments that existed at different times. Different layers show the variety of sediments. The dynamic environment surrounding the glacial ice often included lakes. Lakes formed when ice or moraine debris precluded or slowed the drainage, and these bodies of water collected sediment from the meltwaters that flowed into them. Lakes could be ephemeral and disappear in a sudden outburst flood, but some persisted for decades or longer. Lake bed sediments in the Point Whitehorn bluffs sometimes feature varves, or laminations, produced by annual variations in the sedimentation, as they collected less meltwater in the winter. Large glaciers produce copious quantities of meltwater, and it must flow somewhere. The outwash carries sediments, mud, sand, gravel, pebbles, which are deposited as they drop from the flow, often changing the flow into another direction. These kinds of outwash flows show cross-bedding. These diversely angled layers formed on inclined surfaces like ripples within the bed of the watercourse they were carried in. Studying a section of cross-bedded deposits can show how currents changed over time. The predominant layer in most of the bluffs at Point Whitehorn is glacial till. This is made up of unsorted sediments, rocks, clay, sand, boulders, eroded and plucked by the glacial ice, entrained by it and carried, sometimes hundreds of miles. It is often highly compacted, difficult to dig in, and somewhat impervious to water. Its resistance to erosion means that it typically forms steeper cliffs and slopes. On the top of the bluffs is a layer of soil. Soil has formed in place on top of the glacial debris below it, and it hosts the plant life and critters that delight us on a walk along the Point Whitehorn Trail. The less permeable glacial till traps water in the soil layer, creating the wetlands that necessitated building all of those bridges on the trail. Tumbling back down the bluff to the bottom, we see a fan of debris at the toe. Just as all this landscape was brought here by water in solid form, it is now being taken away by water in liquid form. Ultimately, most of the bluff retreat on the shores of the Salish Sea is a result of landsliding. The effects of erosion on the bluffs are easy to see if you are a frequent visitor to the shorelines of Point Whitehorn. Something changes every day. Water finds a path to seep into the glacial layers. Eventually, the saturated material gives way and slumps to the beach. Most landslides on these bluffs occur in response to either heavy precipitation or elevated groundwater conditions. Once it is within reach of the waves, they will begin to move it. The swash and backwash will move the material up to the beach at the angle of the prevailing wind with each swash, and it will tumble down the slope of the beach with each backwash, slowly edging it along in the process called longshore drift. Transported by longshore drift, the material fallen from the bluffs of Point Whitehorn replenishes the tidelands and beaches of Birch Bay to the north. And it builds the spit of Sandy Point to the south. Those giant boulders that are scattered up and down the beach at Point Whitehorn are a particularly notable attraction. Look closely, and you will see that they are composed of a wide variety of bedrock, granites and granodiorites, some with blebs of country rock captured by ascending magmas, wildly folded metamorphic rocks, and conglomerates. Many of these rocks traveled from the faraway coastal mountains of British Columbia, brought here by the glaciers, bequeathed to us now as erosion of the bluffs reveals ever more of the erratics contained within the glacial till. Some display the parallel striations scratched on their surfaces by a slow scrape against other rock, propelled by advancing ice. Inexorably, the land is being carried away. Expensive and ultimately disruptive attempts to stanch the effect of water on the bluffs are seldom effective, as bulkheads affect little control on landslide activity. The rate of bluff recession in any spot depends on wave action, the composition of the bluff, the width of the beach, and the height of the beach berm. Recession rates are on the order of a few centimeters a year or less, and retreat is likely to occur as single landslide events separated by years or decades. The glacial ice of ages past have given us a great gift at Point Whitehorn. As you gently explore the point and discover your own answer to what's the point? Explore the tide pools and pause for a moment to think about the geologic processes that have brought about the scene we all enjoy today. Enjoy your visit to Point Whitehorn.